Okay, let's look at the local extrema, right? Extrema is a fancy word for both maximum and minimum, right? It's a combined word. All right, so here's the definition. We say f of c is a local maximum if there is an open interval I containing c and f of c is always greater than or equal to f of x for all x in that interval. So if you look at the local region, that's basically the highest value, right? So here, for example, here, look at this guy, right? You can look at the small interval, say here, I'm gonna just go straight down, small open interval here to here. So let's call that interval I, right? So if you compare this value right here with any other value on that interval, you can see that that point is the highest point. So that's why we call this guy local maximum, right? And you can find, let's see, you can easily guess what the definition of the local minimum. So I'm gonna just do this here, right? So f of c is a local minimum if there is an open interval I containing c, and the only difference is f of c is smaller than any other x value on that interval, right? So for example, you can see that here, if you look at this local region here, and again interval I, say this one here, then you can see that this is the lowest point within that interval. So that's why this guy is called local minimum. Right, and we can find other local minimum here. This guy, right, locally it's the smallest guy, so this is also a local minimum. Right, and this one unfortunately is not a local maximum or local minimum. It does have a horizontal tangent, so this makes it, this guy is a critical value here, but it's neither local max nor local minimum, right? And here's a remark, right? If you have a continuous function on an interval from a to b, and c is in that interval or open interval from a to b, right? If f of c is a local extremum, right, so it's either local max or local min, then c must be a critical value, right? So let's check that. Right here we have a local minimum. Look at this, right? This point you have a horizontal tangent line, which means that this is a critical value right here, right? Because the derivative is 0, right? So it's a critical value, right? And this is local max here, horizontal tangent line, so we know that that value is a critical value, right? And local minimum here, right, this is not, there's no horizontal tangent line. Actually derivative is undefined, so our f prime does not exist there, right? So that's why it's a critical value, right? So every time you see a local maximum, that c value is always a critical value. All right, that's a remark. All right, that's it. I hope that this was clear.